Hello everyone, my name is Patel Joy and I am a student at Deakin University studying Masters of Data Science. And I have created this video presentation as a part of my task 8.1p code explanation. In this video presentation, I will be explaining my solution that I have created for the account management system as a part of my task 7.1p for the unit SIT771 Object-Oriented Programming. Before explaining my solution to the account management system, I would briefly like to discuss some of the concepts of the object-oriented programming that have been used in this solution. Encapsulation. The word encapsulate means to cover up or hide. Encapsulation means hiding certain aspects of or details of the system from the user and only showing him what's necessary. Encapsulation aims to hide implementation details, logic of the system, or the way in which the calculations are performed. All of that is enclosed or sort of hidden from the user. In object-oriented programming, encapsulation is attained using access and scope modifiers. Access and scope modifiers like private, public, protected, etc. are given to the fields and methods to limit their visibility from the user. Next is abstraction. Now, abstraction means taking the essence of something and creating a true representation of it. Now, this representation that is being created using abstraction, it resembles the object very closely, and it is like a true form of that object. Object-oriented programming uses objects to represent the real-world entities in the program. Next is inheritance. Inheritance simply means to inherit from someone else. In object-oriented programming, using the concept of inheritance, classes, they can inherit the certain attributes or behaviors from other classes. Using inheritance, we have the ability to extend classes and avoid code duplication instead of reusing the same code. The class which is being extended or inherited is called parent class or base class, and the class which inherits is called the child class or the derived class. This is like similar to a parent-child relationship where a child inherits some of the features like facial features, voice, etc. from their parents. So similarly, in object-oriented programming, classes will inherit it from the parent class and can use those features or behaviors. Polymorphism. Polymorphism means one name and many forms. It refers to the ability of an object to exhibit multiple forms depending on the context. Using polymorphism, a parent object variable can refer to the child objects as well. Considering an example of a shape class. Now, a shape can have multiple child elements like a rectangle shape, circle shape, a triangle, an ellipse, etc. So we can create a shape variable and can refer to any of the shape objects using polymorphism. This is the UML class diagram for the account management system. This diagram depicts the use of abstraction, as this describes a complete view of the system and how the system looks like. Each rectangle in the class diagram represents a class, and in object-oriented programming, a class is a real-world representation of an entity. Here the bank class has two fields, account and transaction, that will store the list of accounts and transactions. Then it can perform operations like adding an account, getting an account, printing the details of account, executing the transactions, and printing the transaction history. The account class has two fields, that is the balance and the name, and it can perform operations like printing the account details, withdrawing and depositing money from the account. The transaction has fields like amount to store the transaction amount, executed and reverse to store the status of the transaction, and date stamp to store the date and time on which the transaction took place. There are three child classes of the transaction class. Deposit, namely deposit transaction, transfer transaction, and withdraw transaction. These classes have certain characteristics or features in common, like they all have an account on which the transaction will take place, the amount that is involved in the transaction, the status of the transaction, and the success or failure of the transaction. So since these classes have fields in common, we have tried to create a transaction class which has all the three classes common attributes in it. So here the concept of inheritance is utilized. In the program class, the user can only see the program menu and options like performing certain actions like depositing, withdrawing, transferring, or printing. The details of the implementation of how the deposit occurs, how the withdraw is performed, or how bank account transfer works between accounts, or how an account is created, or how the printing of the details is done, it is kept hidden from the user. So here the concept of abstraction comes into the picture. Another class which is declared here is the enum class. Now enum is a special class that is a class of constants, and it represents constant values. Now talking about polymorphism, all the three methods in the transaction class are inherited by these three child classes. So when creating a transaction object, using the transaction object, we can access the objects of the deposit transaction or transfer transaction or withdraw transaction. So from the parent objects variable, we can access any of the child objects variable. So this concept here that is utilized is polymorphism. Now I will explain how the system works. So first of all, when the program starts executing, it will first of all create a bank object. Then it will ask the user to select an option from a list of options. The options given to the user are creating a new account, depositing money into the bank account, withdrawing money into the account, transferring money into someone else's account, printing the list of accounts, printing the list of transactions, or quitting the program. This is the list of options that are given, and this is the how the interface of the program looks like. Based on the user selection, it will perform certain uh, functions like depositing money, withdrawing, transferring, or simply printing. So let's look at an example. Suppose a user creates an account. So first of all, it will ask the user to enter the name of the account. Then it will ask the user for to enter the starting balance of the account. It will check if the balance entered by the user is valid or not. If the balance is valid, then it will simply create a new account. Now let's say the user wants to deposit money into the bank account. Then the bank object is passed on to the deposit method, and it will try to deposit the money. So here the do deposit method is called, and it will first of all check if the account exists or not. So whatever the account was passed by the user, it will be checked first for its existence. If it exists, then the program will ask the user for the amount that is to be deposited. Again, it will check if the value to be deposited is valid or not. If the value is valid, then it will create a deposit transaction object. That deposit transaction object will be passed on to the bank object for its execution. The bank object, it will try to execute the transaction. So based on the type of transaction object that is created, that is either a withdraw transaction object, deposit transaction object, or the transfer transaction object, it will try to execute the corresponding transaction. So here, since the transaction type was deposit transaction, it will try to execute the deposit transaction. In the deposit transaction, since it is being inherited, we are here overriding the execute function. So first of all, it will call the execute method from its base class, that is the transaction class, and then it will try to deposit the amount. Here this amount is simply checked, and if it's valid, then it is added into the user's account. And so in this way the value is successfully added into the user's account. Similarly, the withdraw transaction is done, and transfer transactions done. So this is how I implemented my account management system solution using object-oriented programming and its concepts like abstraction, polymorphism, inheritance, and encapsulation.